Chapter 1.8.7 Controlling Access to the Kubernetes API. This page gives an overview of how access to the Kubernetes API is controlled. Users can access the API using tools like kubectl or client libraries, or by making REST requests. Authorization can be granted to both human users and Kubernetes service accounts. Requests sent to the API go through multiple stages as shown in a diagram. Transport security. The Kubernetes API server typically listens on port 6443, but can be changed to 443 using the secure port flag. It is protected by TLS and presents a certificate that can be signed by a private CA or a recognized CA. The certificate and private key can be set using flags like TLS-cert file and -TLS private key file. To trust the connection, the client must have a copy of the CA certificate in their call/kube/config file and may need to present a TLS client certificate. Authentication. Once TLS is established, the HTTP request moves to the authentication step, as indicated in step 1 of the diagram. The cluster creation script or cluster admin configures the API server to run authenticator modules, which examine the headers and/or client certificate of the request. Authentication modules include client certificates, passwords, plain tokens, Bootstrap tokens, and JSON Web Tokens. Multiple authentication modules can be specified, with each one tried in sequence until one succeeds. If authentication fails, the request is rejected with HTTP status code 401. If successful, the user is authenticated as a specific username, which can be used in subsequent steps. Kubernetes uses usernames for access control and logging, but does not have a user object or store user information in its API. Authorization. After a request is authenticated as coming from a specific user, it must be authorized by checking if the user has permissions to complete the requested action. This involves verifying the username of the requester, the requested action, and the object affected by the action. Authorization is based on existing policies where users are granted specific permissions. Kubernetes authorization requires the use of common REST attributes to interact with organization-wide or cloud provider-wide access control systems. Different authorization modes are supported, including ABC mode, RBAC mode, and webhook mode. When creating a Kubernetes cluster, administrators configure the authorization modules that should be used in the API server. If multiple authorization modules are configured, Kubernetes checks each module, and if any module authorizes the request, it can proceed. If all modules deny the request, it is denied with an HTTP status code 403. To learn more about Kubernetes authorization and creating policies using the supported authorization modules, refer to the documentation. Admission control. Admission control modules are software modules that can modify or reject requests that create, modify, delete, or connect to objects. They can access object contents and set complex defaults for fields. These modules are called in order, and if anyone rejects a request, it is immediately rejected. Once a request passes all admission controllers, it is validated using validation routines for the corresponding API object and then written to the object store. Auditing. Kubernetes auditing records and tracks all activities in a cluster, including actions by users, applications using the Kubernetes API, and the control plane. These logs provide a comprehensive security overview of the cluster's operations. More information on auditing can be found in the provided link.